Okay, so first of all, I want you to get out the assignment from yesterday so we can go over it and you can check your answers because day 2 kind of builds right off of this. So, you know, if you don't have it finished, you can pause the video and you can copy it down, look at my work. 6 and 9, most people got through those yesterday, but that's where you have to write the equation. You can look at my work here. The I should cancel out, and so this is the answer on number 6. Number 9, as I said in class yesterday, my advice is like do these two first, and you get x squared minus 5x plus 6. Do these two second, and you get x squared plus 1. And then when you work those out, you get this answer. If you have an I left in your answer, you know that somewhere the math has gotten messed up, so you just have to go back and check your work. Also remember it's a function, so it has to say y equals or f of x equals, or you don't get the right answer here. 17 through 20, just checking the multiplicity. I believe those are the answers. 27 and 30. Step 1, PRZs, just plus or minus 1, plus or minus 5. Fantastically, 1 works. So that's a 0. I divided it out and I got this quadratic, which I did the quadratic formula, and I got negative 19 under that square root, so I simplified it to this. Those are the zeros. The new part was writing it as a linear factorization, and so again, I made it so that the 2 went away. You could have also said x plus 1 minus I radical 19 over 2, and x plus 1 plus I radical 19 over 2. And that also works. Notice it's a degree 3, and we have 3 zeros. And then the last one was a degree 4, so there's a lot more work to do. Also some fraction PRZs, but I found negative 2 to work first. It's okay if you found 1/3 first. Your work's going to look different, but our final answer should be the same. So I found negative 2, and then I had a cubic left. And so I went back and I guessed some more until I got 1/3 to work. So a 4th degree, this would be a 3rd degree, and then finally I get down here to a quadratic. I noticed that all of them had a 3 in front, so I divided everything by 3, and because it's an equation, I can do that. But if you didn't divide by 3, this would be the answer that you get before you simplify it. Like you would get the square root of negative 27, which you could break up as 9 times 3, with an I guess. And so you get the same answer, but you have to simplify here. So if you don't divide by 3 at this step, you have to divide by 3 at the end because they all have a factor of 3. And so then you can still get the same answer that I got. Again, we have real answers, and then we have our complex or imaginary answers, which counts as 2. So when I wrote them as quadratic factors, this is what I got. And again, you could write that as 1 plus, or x plus 1 minus I radical 3 all over 2, right? You can leave it as a fraction. I just think it looks better not as a fraction. But please check your work, check my work, and then that way you can ask me questions over it. Okay? Okay, so I also want you to get out the notes from the video. And if you haven't watched the video, you need to do that first before you start this assignment. But 2 big parts of this video. One of them was dividing out imaginary zeros, which is a lot of work. I left the textbooks are up here on my desk. Look in section 2.5, and there's another way of doing it besides synthetic division. If you're a fan of long division, you can do it with long division and work it out that way, and some people find it to be easier. It's still a lot of work. But just please try to watch that process if you haven't done it yet to do it. But the other part of the video was that we can talk about linear factors, but we can also talk about irreducible quadratic factors. So this is where vocabulary becomes really, really important. If the directions say linear and irreducible quadratic factors, it means if it doesn't work out nice, you can leave it as a quadratic. So if you can't factor it, you can leave it alone. So I left this one for us to do. So the step 1, what am I going to do? I'm going to do my PRZs and take factors of 12, which is a lot, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, over factors of 1. So at least I don't have any fractions to do. And then if I was a thinking person, I would have had this done already, but give me one quick second here to get a 0 plus x squared. Maybe you tried this already and you have one, but too bad I can't hear you telling me the answer, right? My calculator is not working the way I want it to work. Graph. I'm trying to cheat and use the graph, and it's not working so well. Oh, -1. I think -1 works. Let's try. If I plug -1 in here, I get -1, -3, 3, -4, -12, which is 0. Yes? And we can just keep guessing. I also think this is one where you could do the factor by grouping, but that doesn't always work, so I'm just going to keep guessing. And so I would keep plugging numbers in, and I think 3 is another one that works. Just to kind of save you time, I'm going to tell you what the answer is. It's the hardest part, I think, is plugging all those numbers in. I get 0, that's 0, that's 12. So again, x to the 4th, divided out once, it's x to the 3rd, divided out again, and I'm left with x squared plus 4. So my zeros right now are x equals -1, x equals 3, and x squared plus 4 isn't even that bad to solve. I could solve it, but do you agree that I would get an imaginary number if I solve this? Like I would subtract 4 and get x squared equals -4. So this is what we call irreducible. Irreducible means it doesn't give me rational numbers. It gives me irrational or imaginary. So if I was going to write this out as linear and irreducible quadratic factors, I'm going to get x plus 1, I'm going to get x minus 3, and I'm going to get x squared plus 4. This looks like more of what we've seen in the past without all the imaginary stuff, with the square root stuff, right? This looks nice, and we're just going to leave it like that. So again, the directions become really, really important. So I've posted on Classroom this assignment as a PDF. Please work on it. Please try it so that you can ask me questions on it for tomorrow. So 33 is the hard one. 33 is like the one that I did at the beginning of the notes. Again, you can get the textbook and you can look at the example in the notes. In the textbook for section 2.5. You can look at the long division example, but please try it. You're not going to know how to do it if you don't try it. And then 39 and 42 are like the last two in the notes. If it doesn't work out nice, leave it, right? That's why I highlighted linear and irreducible, but still, PRZs, find one that works, plug it in. And then there's just a couple questions here. Oh, go back really quick, sorry. I remember there's one more thing here. I said every polynomial function of odd degree with real coefficients has at least one real zero. Tell me why that's true. And there's a couple reasons I think it's true. I always think it's true because of in behavior. What do we know about the in behavior of an odd degree function? We know one arrow points down and one arrow points up. So won't at some point, if one arrow points down and one arrow point up, it'll have to cross through the x-axis at some point. Sometimes people think about imaginary numbers come in pairs. So if you have a degree 3 or any odd number, the number of imaginary or complex zeros has to be an even number. So there's always one left over to be a real zero as well. Now, even degree functions don't have to have a real zero. They could have all imaginary zeros. Think about the quadratic graph that looks like this, right? It doesn't have to cross the x-axis. So that's something to think about. Sorry, these questions made me think about that. So 33, 39, 42, they have some work to do, but 46 and 57 are more like thinking questions. So talk to each other, help each other, get the textbook, look in the textbook. There's examples in the textbooks too to help you. And then please watch the video for 2.6 as well. And as I posted on Classroom, I gave the retest to Miss Bai. If you want to retake a test in there today, you can. And hopefully I'll be able to come back to school tomorrow.